Hey, everybody. Happy New Year to everyone and to your families from all of us here at CML Online, your CSEC material expert. And today we have an exciting package where we're going to focus on some important topics that will be coming for January 2025. And will serve as a great review for the CSEC mathematics in general. We're going to be looking at the June 2024 paper 2 questions 1 through 10, some important examples, and some adequate practice questions. All right, so let's get into it. First up, the instruction set for paper 2. All these instructions are important, but we're going to be paying particularly close attention to points number 4, points number 7, and points number 10. So let's do it in reverse order. It says here, point number 10, all diagrams in this booklet are not drawn to scale unless otherwise stated. That is true. CSEC doesn't usually draw diagrams to scale. However, they tend always to draw diagrams to proportion. That is very important. And you can see that clearly in something like the circle theorems. Circle theorems, the angles are drawn in proportion to one another. In fact, it's almost impossible to do a circle theorem question and not have things in proportion. So let's look at that example. This is a circle here, clearly. All right. And let's suppose we have the very popular question of the angle at the center, okay, and the angle at the circumference. So if you're looking at this carefully, you can clearly see which angle is the bigger one. Now, it does not mean you can find out the exact amount of degrees, but we can clearly see by inspection that the angle at the center is actually greater than the angle at the circumference. You'll see that? Which means if I say the angle at the center is going to be 50 degrees, right? It's impossible for you to see that the angle at the circumference now is 60 degrees, right? So just simply by looking at it, you can tell which is the bigger angle. So we all know this theorem. This theorem is very popular. It's the angle at the center is twice the angle at the circumference. Hence, if the angle at the center is 50, then the angle at the circumference is going to be what? Very good. It's going to be 25. So that is one way, that is one help up you can have with you in the exam. Okay, knowing that things for CSEC are drawn not to scale, but they are always or almost always drawn to proportion. This is also true in things like pie charts, right? And bar graphs. So remember that. This will come in handy, you never know. Pie charts are drawn to proportion. Bar charts are also drawn to proportion. How you all feel about that? Now charts. Awesome. Any questions? Okay, great. Now let's look at point number 7. It says here, a list of formulae is provided on page 4 of this booklet. Now, many times for CSEC, you may get stuck in a question. Always remember, you have a list of formulae there to help you. Some students may go through the entire exam and never once look at the formula sheet. Look at the formula sheet when you get stuck, or briefly go through it just at the beginning, just to scan it, so it will be there in your brain. Something will stick in your brain, and as you go through working from question to question, something will occur to you, and you will flip back to it and be able to get the solution. All right? Also, when you're stuck with a question, check the formula list. Something may trigger, even if the formula is not actually there, just by looking at that formula, something can trigger in your brain. Please utilize the facility of the formula list. And lastly, as I said in reverse order, we're going to look at point number 4. It says numerical answers that are non-exact should be given correct to 3 significant figures or 1 decimal place for angles. Notice it is 1 decimal place for angles in degrees. Okay? But CSEC will tend to tell you or ask you for decimal places, any amount of decimal places. All right? Usually 2 to 3 thereabout. But they want 1 decimal place for angle in degrees, but 3 significant figures for all answers, apart from angles. That's the understanding here. Okay? And it's important to distinguish between significant figures and decimal places. Just remember that for significant figures, you always count from the left of the entire number. Okay? It can be a whole number, it could be an integer, it can be a decimal. All right? When you're dealing with significant figures, you always count from the left of the entire number as opposed to decimal places. You count differently. For decimal places, you always count from the right of the decimal point, right? And you almost saw a balloon there. You'll see that balloon in a second. So you count from the right of the decimal point to establish the decimal places, and you engage in the same rounding off and approximation. So both significant figures and decimal places involve rounding off and approximation. However, please remember that decimal places and significant figures are not the same. All right? How you all feel about that? Yeah, awesome. All right, great. So let's get into the first question of the paper 2. So this question 1 contains square roots, decimal places, ordering of number formats, proportional reasoning, standard form, etc. Use this as a rough guide to what question 1s are going to be like. All question 1s are going to involve these types of topics. Okay, you can always refer to the actual syllabus if you want the exact listing, but generally, these topics will come in question 1. So for example, you'll never see a bearings question in question 1. Very unlikely. And if you do, it will be something involving one of these topics. But generally, for question 1, these are the topics. All right, so take a note of them. You can always stop the video or the recording at any point and take a note of it. Awesome. Let's get into the fabric of question 1. All right, so it says here, calculate the value of the square root of 7.1 squared plus 2.9 squared. Right? Notice the square root sign is over everything. So the correct way is you can figure out 7.1, square it, write it down, and then figure out or calculate 2.9, square it, write it down, and then add 2 answers together, and finally get the square root of that answer. Okay, so that method is the usual method. So I'll say it one more time. You type or you enter 7.1 into the calculator, you square it, write it down, clear your calculator, then type in 2.9 squared into the calculator, get the result, write it down, add these 2 results, and then get the square root of that answer. Okay, so that is one possible way to work it out with the calculator. There's another way as well, which I highly recommend, using the Sharp calculator. I'll tell you the exact one in a second. So it involves the second function, x squared. Notice very carefully that second function is in orange and the square root sign is also in orange. All right, so whenever I type the second function button I'm engaging the square root, not the x squared. Understood? Is that clear to everybody? Awesome. So second function, x squared, I'm finding the square root. That's going to be open brackets. This open brackets, I'm about to find the square root of everything in the brackets. Okay, so I'm going to put second function, x squared, open brackets, and then I'm going to type in another bracket. This bracket is for this small bracket here. You all see that? This bracket here is this bracket here. Okay? Yeah, you all cool with that? So the next thing I'm going to type in is the 7. So let's just do that. So 7 goes there, point, point, 1, 1. Close brackets, close brackets. Squared. How do I do this squared? I have to put x squared without the second function. Remember, the second function before the x squared engages the square root. So in this case, I'm just going to put x squared by itself. Okay, so all of this here, you see it here, open brackets, 7.1, close brackets, x squared is actually this piece here. So this here is actually this here. Okay, and of course the square root sign is above it, and I'll show you how the square root sign has been relayed to the buttons in a second. Let's just focus on the 7.1 whole square with the brackets in front here and the brackets here. Bracket, bracket, 7, 7, point, point, 1, 1, close brackets, square, square, x squared. X squared means 7.1 is being squared. Notice again, I did not put the second function here. So this does not mean square root as before. This only means square. And I'm going to do the same thing for 2.9. Let's check it out. So it's going to be 2, or the plus sign, right? Rather, first, plus sign is first, then open brackets, then 2.9, close brackets, x squared. And then another bracket, because I want to square root everything. So this bracket here, right? And this bracket here means that everything between them is being square rooted, just as it's depicted here in the question. Okay, so just remember the number of brackets going this way should tend to equal the number of brackets going that way. Right, so I have 1, 2, 3 brackets going in this direction to your right, and I have 1, 2, 3 brackets going in the opposite direction. Right, that's a good rule of thumb to remember, but when you enter it into the calculator like this, you do everything one time, and it's only one mark. Right, so practice with your calculator how to get this done. And I highly recommend the Sharp DAL calculator. So that's going to be this calculator here. Sharp DAL EL 506CS. Okay, you can get it for at basically any retail stationery store throughout the country, wherever you are generally. And if you have a calculator just like this, you'll be able to enter it similar to here or exactly like this. If you don't have a Sharp calculator, don't worry about it. You find what works for your calculator. But this is what the calculator that I recommend and I'll be using for this session. All right. So when you have done all of that, Then you press the equal sign and we're going to ready to get the answer. Now, again, we have two methods to do it. As I said initially, you can find 7.1 squared, write it down, play your calculator, then find 2.9 squared, write it down, play your calculator, add them both, and then find the square root of that result. Many people may find this much more convenient. However, this method is, as well can give you the answer quicker. But for speed and accuracy, I think you should practice both and get to know your calculator. This calculator, once you get to know it, it will be of great help in the exam, right? Especially for paper 2 and paper 3. So this is a great exercise in getting to your calculator better. Right, so having said all that, let's get the answer. Of course, you should press equal sign at the end. It's not noted here, but you should definitely, right? So you will get 7.6694, etc. So this long number is not what CSEC requires. What do they require? Two significant figures. Significant figures, as I said before, begin from the left. So we start counting from the left this way. Every digit that's not zero is significant. Don't forget that every digit that is not zero is significant. So this is going to be one significant figure, two significant figures. So at that point, what you do is you count from the left up to the second significant figure. All right. So it's going to be the 6 right here. Now, the 6 is after the decimal point, but that's not what we're focusing on for significant figures. We're simply counting the non-zero digits. So this is the first significant figure. This is the second significant figure. Have it written down or look at your calculator and then look at the number to the right of it and ask yourself, is this number in the 5 or more category? What do you all think? The answer, it is in the 5 or more category. When that happens, what you do is you add 1 to the 6 and make it 7. So all of this long number simply becomes 7.7 to two significant figures. Notice I wrote down 7.6694. So for the actual exam, just write about like if they want two significant figures, write down much more than two, like 4, 5, or 6. And then that will give you the liberty and the better accuracy and the freedom to actually estimate for two significant figures, right? And even if you count from the left here, you will get the same answer. This is the first significant figure. This is the second significant figure. Is this digit here? So we're going to circle this digit. And then we're going to underline this one. And is this number in the 5 or more category? The answer is yes. So we add 1 to this 6, make that 7.7 and ignore the rest. Notice I just simply I put nothing after that. So this is the first significant figure, second significant figure. Hence, we have two significant figures as the final result. Does everybody understand that? Put a Y in the chat if you totally understand it. Hey guys, awesome. Let's continue. And with that, let's look at the decimal places. And I will show you how they differ. So with the decimal places, you're going to put back the same number. Okay? Same numbers there that we got from originally. Right? Don't make that error and put 7.7 here and then get two decimal places. It's impossible anyways. Right? So two decimal places from the original number that you get with when you did the calculation with this expression here. And for two decimal places, remember decimal places, we count from the right of the decimal point. So this is the decimal point and we go to the right. First decimal place, second decimal place. Right? So we're just going to circle that number. And in that case, we will end up with this 6. And now what we do is ask ourselves, after we circle the second decimal place, because we want it to 2 decimal places, we circle the second decimal place, and then we look at the digit to the right of that. Then ask yourself the same question. Is this number in the 5 or more category? Yes or no? Hey guys, yeah? All right, so this number is in fact in the 5 or more category. In other words, I'm saying, is it 5 or more? Right? I expressed that as a category. So this is in the 5 or more category. So I'm going to add 1 to this 6. Okay? Make it 7 and ignore the rest of the number. So that becomes 7.67. Again, I have the same 7.6694 like up here. And from the right of the decimal, when I'm going to the right of the decimal point, 1, 2, I can still circle here and look at the number to the right of it, which is 9. It's in the 5 or more category. So I add 1 to this 6, makes this 7, and ignore the rest of the number. So the answer here is 7.67, and the answer here is 7.7. Again, CSEC requires you to have 3 significant figures, but in this case, a different level of accuracy is needed. Okay? And in this case, a different number of decimal places is needed that we saw in the original instructions, right? But remember, with the original instructions, they were talking about for angles, not for general numbers, other numbers, right? They were speaking about only for angles. So for the decimal places, it may vary from question to question. The significant figures for all questions should be 3, unless otherwise specified like here. I hope that is crystal clear to everybody. All right, so go back and stop the recording at any point in time and go back and make sure you thoroughly understand the material. Awesome. Let's press on. All right. So let's look at part 2 of the same question 1. It says here, write the following quantities in ascending order. So the best way is to write each one as a decimal. So 12 divided by 25 is going to be a particular decimal, and 47% is the same as saying 47 divided by 100, or we can look at it as powers of 10. The decimal point is at the very end here, and then you jump 1, 2, and the point goes here, so this becomes 0.47. And when you say 12 divided by 24, you should get 0.48 as well. Use a calculator while I'm writing. By the way, we should all have our calculators out, right? No worries. So have your calculators out. Try 12 divided by 25. You should get 0.48. And then write them all underneath each of them. Even though it's 0.46, write it underneath. So, right? So this is all in one format. That's a very important point. For you to put numbers or quantities in ascending or descending order or any particular numerical order, what you must do is have each of those number formats the exact same thing. So all of them should be all fractions, all decimals, all percent. You should never have them varying. You will not get a proper or correct assessment. It is best to have them all in the exact same format. In this case, the easiest option is going to be the decimal. It will be difficult to put this into, not difficult, but maybe cumbersome to put this into fraction and this as well. Because with fractions, you must have them, they must all have the same denominator as well. So that's an additional work for only one mark. So do the simpler, easier, accurate thing. Right? So once they are like this, we can see that they look like money. This looks like 48 cents, 46 cents, and 47 cents. Are you all seeing that? What do you all think? So if you can see that, then clearly we know which is the first one or which is the smallest numerical quantity is going to be 0.46 followed by 0.47 followed by 0.48. So clearly, we can now put them exactly in the order that is required, which is ascending order. Ascending is from the smallest digit, or sorry, the smallest number to the largest one. Descending is from the largest to the smallest. Right? So who goes first, who goes second, who goes third? In this case, the 0.46 goes first, 47% goes second, and the 12 over 25 goes last. This is an important point as well. When you're answering the question, after you have them in decimal, don't put right back these decimals here. Put back whatever represented them originally from the original question, right? So since the second one is 47%, not 0.47, put 47% here, and the 0.48 was related to the 12 over 25. So put back the exact numbers that they wanted in this ascending order to begin with. Right? So that's good exam practice and good exam protocol. So the final answer is 0.46 is less than 47%, is less than 12 over 25. And this represents these numbers in ascending order. Right? Are you all cool with that? Awesome. Let's press on. It says here, Mahindra and Jaya shared $7,224 in the ratio 7-5. How much more does Mahindra receive than Jaya? Right, pretty much straightforward question. It's 2 marks. It involves something thinking, but not much. First up, let's look at the fact that who gets more between Mahindra and Jaya. This all depends on how the ratio is written. Who comes first, who comes second? Mahindra gets 7 shares and Jaya gets 5 shares. Notice the ratio is written exactly in the way of who gets what. So Mahindra comes first, 7 is first, so that's how we relate it. Jaya comes second, 5 is second, so that's how we relate it as well. All right, is that clear to everybody? That's how ratio is always understood. It is done in respective order of the people that something is being shared between or among. In this case, it's going to be $7,224. We're going to share it in the ratio. Clearly, Mahindra gets more because his share is bigger than Jaya's share. And the expression how much more actually means to take away. Don't be sidetracked or be segued by the more, thinking it means to add. How much more? This whole expression is actually a subtraction expression. Okay, and you can think of it in real life. If you are 12 years old and your brother is 15 years old, who is between you and your brother? How much more years are between you and your brother? Okay, or how much older is your brother than you? It's 15 take away 2, which is 3. Okay, so not just the actual word, but the context and the expression tells you what that word or expression or words are all about. So in this case, it's going to be taken away, and we're going to take away Jaya's share from Mahindra's share. We know Mahindra's share is 7, and Jaya's share is 5. So it's going to be simply 7 take away 5, which is 2 shares more for Mahindra. So Mahindra gets 2 more shares. But that's not the question. The question says, how much more money does Mahindra get? If you sum up to this point, you may get a mark, right? But be careful of being too easily satisfied with your efforts. That could happen in an exam. That's with anxiety and with the desire to finish, you could fall under overconfidence as well. When you are quickly satisfied, be careful. Look at the marks. Look at the marks and look at the working and see if they mesh. All right. So that's a very good important exam note to remember. So 2 shares more for Mahindra. Now we have to figure out how much is 1 share because we have $7,000 plus. All right. And everybody has a share. So if Mahindra gets 2 shares more, I want to know not just how many shares, but what that equates to in terms of finances. So, all the shares add up to 12, 7 from Mahindra and 5 from Jaya. 7 plus 5 is 12. So the total amount of shares is going to be 12. Then we can relate the shares to the money. So since total shares equals total money, in this and every case, right, where we count up all the shares and we have a knowledge of how much all the money comes up to, you can see 12 shares is equal to $7,224, which means one share is going to be 7,224 divided by 12, which is $602. How you all feel about that so far? Hey guys, awesome. All right, so one share is going to be $602, which means Mahindra share, 2 shares. To calculate that, all we simply do is multiply 2 by 602, which is $1,204 or $1,204, which means Mahindra gets $1,204 more than Jai. Is that clear? Who understands this completely? All right. Also, Risha has been making a big comeback with CSEC as well. So I'm going to simply upload a similar video to this where I deal with shares and ratio, and you all can get it in the Google Classroom as well. All right, awesome. Let's press on. The other question says the present population of Portsmouth is 550,000. It is expected that this population will increase by 42% by the year 2030. That's the expectation. Write the number 550,000 in standard form. Well, pretty much straightforward. We write on the number 550,000. Then we manipulate the decimal point. Again, decimal is making a big show in the exam, right? So be able to understand decimals and decimal point. You'll be able to understand numbers in general. As a matter of fact, this is the age of the decimal system and has been so for many years. So the decimal point, if you don't see a decimal point, what do we do? Decimal point, if you don't see a decimal point, is at the very end of the number, always. Not sometimes, always. Right? So don't forget that. So what we're going to do is take the decimal point and then move backwards. 1, 2, 3, 4, and 5. And for each hump, we're going to count each hump. 1, 2, 3, 4, 5, which is the same number that we just got. So when we want to express this as a standard form, we're going to move the decimal point until we come to 1 digit. And that 1 digit cannot be 0. It can be any other number, but it cannot be 0. You cannot stop in front of or before a 0. It must be a non-zero digit, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 0. When that happens, we are able to express this number in standard form. Because of how many jumps we made, it's going to be 5.5 by 10 to the power of 5. And that's it. It's 1 mark. So it can't be that difficult. Remember, if you jump into the left, it's going to be, this 5 is going to be positive 5. Suppose we would jump into the right. What would have happened in that case? So let's check it out. So it's going to be, let's say, 0.000, 0, 5. Okay? Put the 5 here. Yeah. In this case, what would the number look like? So we can't go to the left because if we go to the left, there are no non-zero digits to the left. There's just more zeros. So we need to find the non-zero digit. So in this case, we went to the left because we're trying to find the non-zero digits, but we just want one of them to stop before. In this case, there are no non-zero digits to the left, so we're not going to jump to the left. We're going to actually jump to the right. So it's going to be 1, 2, 3, 4, 5. And in this case, it's going to be same 5.5, right? It's going to be 5.5 by 10 to the power of what? Who can tell me? 5.5 by 10 to the power of what? Anybody wants to hazard a guess? 10 to the power of 5. Well, you're very close. It would be 5, it would be negative 5 or minus 5. So whenever you jump into the right and you are trying to get to the non-zero digit, right? Notice I didn't go to here because I'm supposed to get one non-zero digit, which is the first 5. If I had made another jump, that would have been 2 non-zero digits. I don't want that. The standard form, I must only have one non-zero digit. And whether I'm jumping to the left or I'm jumping to the right. In this case, I stop just between the two 5s, so it becomes 5.5 by 10 to the minus 5. It's minus whenever you jump to the right, and if you jump to the left, as in the first case, it's going to be positive. You'll understand this? This is 5.5 by 10 to the 5. This is 5.5 by 10 to the minus 5. Okay? They look very similar, but these two numbers are completely different. Okay? If you put money in front of this, a dollar sign, this is $550,000. This is 5.5 by 10 to the minus $5, which is basically no money. Right? So don't get confused and say, well, they're almost the same. They're completely opposite. If you put a minus 5 for this question, you will get 0 marks. This question is with 1 mark, and CSEC does not give half marks. All right? Is that clear to everybody? You're cool with this? Okay, awesome. And with that, let's express the final answer here. It's going to be 550,000 in standard form is 5.5 by 10 to the 5, positive 5. Another word for standard form is scientific notation. Remember that too? CSEC may switch it up on you someday, and you may never know. Okay, scientific notation is the same as standard form. Are you all cool with this? All right, awesome. Let's continue. Which means, number 2, calculate the expected population of Portsmouth in 2030. Remember, this set is going to increase by 42%. So all we have to do here is recognize that 42% is the same as 42 over 100. So I'm going to take 42 over 100, multiply by 550,000, and get 231,000. This is the increase. Again, this is not the answer. Don't have your expectations satisfied too quickly. You may be like, oh yes, it's 42%. I got this answer, that's the answer. Again, it's 1 mark. If you stop here without giving the complete answer, you get 0 marks. CSEC does not give half marks. So it's just going to be 1 mark here. And you get no marks here if you stop at this. You have to take this answer now and add it back to the 550,000 to get 781,000 by 2030. Notice again, this case, we calculated the increase. In this case, we calculate the expected population. Or the expected population. This was the increase in the expected population. The increase in the population, rather. But this one here is the expected population. They are related, but they are not the same. Okay? So you calculate the increase, then you add it back to the 550,000. An easier way to do this, we're simply going to say 1, which is the present population, plus the percentage increase expressed as the decimal. We add them together and we multiply it by the actual number that is the population right now. So 1 plus 0.42 multiplied by 550,000. That gives me 781,000, which is the same as this. Any questions? So you can express the population increase in two different ways. Pick which one you think is easier for you. Also, you can look at the population decrease in a similar manner. In this case, what you're going to do is you're not going to add the 231,000, you're going to subtract it. And that will tell the population decrease. And similarly here, you're going to add this 0.42, you're going to subtract it. And then the result multiplied by 550,000, that's how you're going to know it's 781,000. I mean, another number will come up, which will be the same as when you subtracted it here. Okay? But for this question here, population, expected population is going to be by 2030, 781,000. And they actually do things like these in real life. In census and statistics, it may be in the CSO, Central Statistical Office. They may do things like this all the time. Those of you who are like careers in demographics and stuff like that, you may want to take note of this type of calculation, right? And also that can come in something like the paper 3. It would just be more involved. And this is actually a great SBA topic as well. Something interesting that you could do. All right. How you all feel about this? Comfortable? Not so comfortable? What you all think? All right. So make a comment. Awesome. Let's continue. So we're still on the topic of question 1. And we're looking at the graph below can be used to convert United States dollars and Eastern Caribbean dollars. Using the graph, convert 2 US into EC. Right, so it's pretty much simple. This is the graph here. Let's find the 2 US at this point. You're going to draw a line from the 2 US until it just touches the graph, and then you're going to come down vertically. And this point here is going to be what? What do you think? We know that from here to here is 1, and there are 5 equal divisions between 0 and 1. So 1 divided by 5 will give me 0.2. So each one is going to be 0.2. This is 5, 5.2. This looks like 5.4, right? 0.2 and another 0.2. The line is a bit thick and the grid is a bit not exact. However, you can substantiate it in other sources as well. You realize that the EC in this case is going to be 5.4, right? Or $5.40. So that's the answer for part 1. How you all feel about that? So it's just pretty much simple. It's going to be 1 mark. You draw a line from the 2, because it's 2 US, to this point, and then you come down here. Right? A horizontal line meeting the graph, and then a vertical line meeting the x-axis. And this point is going to be the answer to this. This is 5.4 or $5.40. EC equals 2 US. Any questions here? How you all feel about that? Hey guys, great. So in this question here, it says convert 70 EC to US dollars. And this question is what I like to call a read the room question, right? So if you read the room, you may be able to work this out faster, especially the fact that this is 1 mark. So it may not be involving a lot of calculations. So I'm seeing a 7 here. Sorry, a 70. And I'm seeing a 7 here. So what may be the best option for you? Instead of, some people may draw from here, 10, come up here, get the answer for the US, and then multiply by 7 on both sides. You can simply get how much 7 EC dollars is in US dollars. Draw a vertical line, touch the graph, come across this way. And by the same analysis that I got $5.40, this here is going to be $2.60. Hence, 7 EC is equal to $2.60 US. So 70 is simply, I just move the point one place to the right in each case. Move the point that we don't see, which is here, over to the right, I'll get 70. I move this point that we do see to the right, and in this case, I'll get $26, which means 70 EC is equal to $26 by inspection. And you can, this is perfectly all right. Just do this for CSEC. You can say by inspection, it is $26. You can clearly see that all you need to do is add on a zero in this case and move the point in this case, but actually it's not adding on a zero. You're moving the point once to the right. And in this case, once to the right. Why do you move once to the right? Because you want 70. And 70, you can get 70 from 7 by doing just that. Okay? That's what I call reading the room instead of doing it a longer way and maybe getting stuck and wasting more time in the exam. So just understand that CSEC will put questions like these from time to time, and there's a number of questions that are coming up that will have the same icon. So be on the lookout for it. So in this case, the answer is $26. So 70 EC equals $26. Any questions? Hey guys, awesome. Let's continue. So question 2 talks about parameter, variable expression, formulating quadratic formula, calculating areas of geometric shapes, etc. Right? Again, this can be used as a rough guide to tell you what's coming for question 2. Okay, so take note of it. So it says here, Laura needs to put mesh around 2 seedbeds to protect her seedlings. Altogether, she uses 60 meters of mesh. One of the seedbeds in a rectangle is a rectangle rather, and the other is a square. As shown in the diagram below, seedbed here, this is the rectangular one clearly, and this is the square. It doesn't look necessarily square because of the copy, but this is a square seedbed. The width of the rectangular seedbed is X meters. The length of the rectangular seedbed is 3 times its width, right? Take a note of that, that's very important. The length of a side of a square seedbed is Y meters. This is all information. What you should be doing at this point is taking out your pencil and lightly underlining or circling things that matter to you or may be relevant to the question. CSEC doesn't just write words. They also put specific things into the question, and they're also testing your reading abilities. Don't forget that. Remember, the mathematics is written in English, so they are testing how well you can read. Do not ever forget that. All right? We're just applying reading to mathematics, but it still involves you reading. All right? So brush up on your reading if you can between now and the exam, but do it with the exam past papers. So part A says, using the information given above, derive a simple expression for y in terms of x. So first of all, we established that seedbed A is a rectangle and seedbed B is a square, right? Notice the colors are different as well. That was done on purpose. Next, this question contains certain keywords. We have length, circle it. We have 3 times its width, circle that too, right? Then we need to put this into the diagram. That's a good technique as well. For CSEC, you can actually write on the question paper. Don't make it, it'll be no big deal. Write on the question paper. It's not written here from the actual exam, but write on the question paper so that it brings the question paper a little more familiar to you. And that improves your confidence just a bit by you taking some information and writing on the question paper. It makes the mathematics seem less abstract and closer to your vicinity. So in this case, you just put simple arrow and just put L is equal to 3x, YL, because this is the length, right? The length of the rectangular seatbelt, L for length. That's why I put that L here, equals 3x. Where did I get 3x from? Well, we know that the width is x, right? So the length is 3 times the width. So therefore, the length is going to be 3x. How do you all feel about that? Hey guys, great. Any questions so far? Now then, I put a W here because W is the width. And it clearly said that the width is going to be x. And for this here, this is a square, by the way, right? So we spoke about why the copy looks a bit non-square, but it is a square because they said so. We said that the side, they said that the side is going to be y. So I put y is equal to s. S represents the side of a square. Any side is going to be s, which is the same length. W is the width, which is x. The L is the length, which is 3 times the width, which is 3x. All right, awesome. Next, what we're going to do is we're going to look at this instruction a bit more closely. And if you can check it, if you can look at it, you realize that this looks kind of sus, right? Simplified expression. What does that even mean? Until you realize it's related to the altogether, which is in bold, and the 60 meters. What does altogether mean? Anybody? It means to add. Anytime you have to get a simplified expression, you should have some addition, some operation, addition, multiplication, division, subtraction, and an equal sign. Now, theoretically, people may say that an expression is not the same, does not contain an equal sign, right? But sometimes CSEC kind of makes they kind of they do that. They tend to put the equals, put an expression, but you should have an equal sign in this case because at the highest level, an equation which contains an equal sign is a sort of expression, right? Some people may beg to differ, but generally, if you're supposed to come up with a simplified expression and you see things words like all together and the 60 meters, you're supposed to have an equal sign there somewhere. So we're going to have like total mesh length is going to be equal to 60 meters. Total means, again, the same as all together, which means to add, which means PA plus PB equals 60. What does P mean? P is actually the perimeter. The perimeter of A or seedbed A is plus the perimeter of seedbed B should give us back the same 60 meters. Why? Because Laura used 60 meters and she used it out on all on these two seedbeds. So if you can get the perimeter of A, which is a rectangle, and add it to the perimeter of B, which is the square, it must equal to 60 meters. All right. What's the perimeter of a rectangle? It's going to be 2 into L plus W, which is the column meshes, plus the perimeter of a square, which is 4 times S. So 2 into L plus W plus 4 times S will give me 60. What is length? The length in this case is 3x, and the width is x. So 2 into 3x plus x plus 4 times y will give me 60. Why is going to be y? Because y is the length of one side of the square. Okay? Or that's what they said. One side of the square is going to be y, which means each side of the square is going to be y. Y plus y plus y plus y is 4y. Okay, so you can either add y 4 times or multiply by 4. Multiplying by 4 makes more sense and makes it far more convenient. What do you all think about that so far? All right, which means let's lose the brackets, people. 2 times everything into the brackets. And the 4 by y, when we multiply it, we're going to get rid of the brackets here too. So 2 by 3x will give me 6x plus 2 by x will give me 2x. So I'll have 6x plus 2x from the rectangle. And in this case, 4 by y from the square is 4y. So 6x plus 2x plus 4y equals 60, which means 6x plus 2x will give me 8x plus 4y equals 60. So far, so good. Did we answer the question? No, we haven't answered the question, right? The question says, derive a simplified expression for y in terms of x. In other words, y must be the subject of the formula. Right now, y is not the subject of the formula. How do you know when something is the subject of a formula? Two things. One, it should be on the left-hand side. LHS stands for left-hand side, and it should be by itself. Very important, right? That letter, that variable must be on the left-hand side. But even more important than that, it must be by itself. It should not be attached to a number or a letter. And in this case, the y is on the left-hand side, but it's not by itself. We need to get rid of the 8x. Take the 8x, put it over on this side, it becomes minus 8x. Hence, 4y is equal to 60 minus 8x. Yeah, so far so good. Is y the subject of the formula? Did we answer the question? No, we didn't, because the y is still attached to the 4. What we have to do is break up the union between the 4 and the y. What is between the 4 and the y? That's going to be a multiplication sign. And how do we break up a multiplication? We have to have a division sign. Okay, so what we're going to do is we're going to divide by 4 on this side. When we do that, we're going to break up the 4 and the y. But if we divide by 4 on this side, we must divide by 4 on this side. Okay, so this 4 and this 4 will cancel, and I will have y by itself, and then I will have 60 take away 8x over 4. Any questions? Okay, great. So let's do just that. We're going to put the 4 underneath here, and it's going to look like this. Y is equal to 60 take away 8x over 4, right? So the 4 cancel with this 4 already. That's why I have y left by itself. And I have everything on this side divided by 4. So it's going to be 4 into 60 and 4 into 8x. And that's how I got 15 minus 2x. Right, so let's just explain that a bit further. So 4 will divide into 60 to give me 15. And 4 will divide into 8x to give me 2x. Or 4 rather will divide into negative 8x to give me negative 2x. And that's the simplified expression for y in terms of x. When this says simplified expression, it wasn't clear exactly what expression, but what you have to do when you see things like this, go back into the question and read important words like altogether, right? Altogether means somewhere along the line, yeah, well, it means add to the initial sense. And if you say altogether, she uses this, then you should put these together and realize you should form an equation where you're adding stuff up and putting it equal to 60. And this is how we have the first premise here. This is a very important idea. You may just get 1 mark just for this idea because everything flows from this idea. All right? You're cool with this? Who's cool with this? Who's not cool with it? Don't worry. I'm going to push your button. We'll get through this together. All right? Feel free to stop the recording at any point and then go back and make it clearer to yourself. Let's press on. And so that gives us y is going to be equal to 15 minus 2x. Okay, great. Let's go on to the other part. Part B, it says the area of the rectangular seedbed is equal to the area of the square seedbed. Use this information and your answer in A to write down an expression, or sorry, rather an quadratic equation in terms of x and show that it simplifies to this, right? Similar, this is more direct. See, before they said a simplified expression and they didn't say exactly what. But in this case, they gave you exactly what to do. They wanted a quadratic equation. Okay, so that's what CSEC does it many times. You just have to be able to read between the lines and actually read in the line, within the line as well. That's a very important point as well. So the area of the seedbed, rectangular seedbed, is equal to the area of the square seedbed. Again, this is a great idea for an SBA. So L by W, which is the area of a rectangle, is going to be equal to the area of the square. What is L by W? It's going to be 3x by x, as we said before, is the length and the width of a rectangle, respectively, is equal to y squared. We said that the side of the square is going to be y. So side squared is the same as y squared because the side of the square is going to be y. And the length of the rectangle is 3x and the width of the rectangle is x. So it's going to be 3x times x is equal to y squared. However, remember we know from your answer to A that y was what? Y is 50 minus 2x. So all we need to do is we figure out, replace this y with y squared and set this side equal to this side. But let's look at closely at y squared first. That might be more involved. So y squared is the same as saying 15 take away 2x all squared. All right? So when we square this, we're going to get this result. And how do we square this exactly? 15 minus 2x is going to be simply putting them into brackets and squaring it in this manner. All right, so we're going to put 15 here, open brackets, 15 minus 2x into 15 minus 2x. Okay, so it's going to be 15 by 15, and then 15 by negative 2x. And next, negative 2x by 15, and then negative 2x by negative 2x. When you multiply those and you simplify it, you will get what we see here on the right-hand side. Well, there's another cool way. I will show you how to expand something like this. I'll show you that in a second. But for now, let's do the traditional way. Okay, just like that, the first term by the two terms of the other bracket, and then the second term by the two terms of the other bracket. Remember to include the negative multiplication when you're doing this, right? You all should recall this. This is a standard in the industry. Okay, great. Next, we're going to say hence 3x squared is going to be equal to 225 minus 60x plus 4x squared. Okay, because we just worked out what y squared is, but then we said y squared is the same as 3x squared. So 3x squared is going to be equal to 225, take away 60x plus 4x squared. At this point, you realize that this kind of resembles this. All right? So what you have to do is use your algebra and creativity to force this result to look exactly like this. You understand? This here is a little bit of mathematics, your algebra skills, but with your creativity. Use your observational skills and some level of technical mathematical know-how to try to make this or force this to look like this. In this case, I'm seeing a 225 here, a 225 here. I'm seeing a negative 60x here. I'm seeing a negative 60x here. I'm seeing a plus 4x squared here. I am not seeing a plus 4x squared here. However, I am seeing an x squared. That's a positive thing. And I'm seeing a 3x squared on this side. But I know if I take this 3x squared and put it over on this side, I will be able to take them away, right? And I will get 3x squared. On this side will give me negative 3x squared. So 225 take away 60x plus 4x squared take away 3x squared. This kind of looks similar to this. I'm getting closer. 4x squared take away 3x squared will give me 1x squared, right? So far this looks even more like this, except that this number in front of here, even though I don't see an actual number here, that number is always understood to be 1. Okay? So that's why I have this 1 here, but I can just lose that 1, and I have 0 is equal to 225 take away 60x plus x squared. So in this case, what I'm going to do is, to make it exactly identical, or just simply identical, I'm going to change this around. And I will have x squared take away 60x plus 225 equals to 0. Sure. Any questions here? Who's messing with this? Making sense? Does it make sense? What do you think? Hey guys, awesome. So yeah, so that's going to be the final result there that we got. We actually show that x squared minus 60x plus 225 is equal to 0. We put the word shown, but we don't use QED. QED is only when CSEC says prove, as with trigonometric identities. But in this case, they said show. So at the end, simply put show, right? Some people you may see this as, people may put this, but it's not necessarily correct. But if you do put that, you're not going to lose marks. So don't sweat the small stuff. All right? Awesome. Let's press on. So solve the equation x squared minus 60x plus 225 is equal to 0 using the quadratic formula. Let's look at some detail. This is be making a big comeback, the quadratic formula. So step 1, we need to put the general format of the quadratic right above the quadratic that we have. Why are we doing that? We need to know who is A, who is B, and who is C. So in this case, A is going to be 1, right? The number in front of the x squared is going to be, we don't see a number, so that number is automatically understood to be 1. And there's no number in front of the x. That number, sorry, there is a number in front of the x, is 60, but it's negative. So this is going to be negative 60. Don't forget that. This negative sign is very important. You cannot leave out this sign. The only time you don't put a sign is when that number or letter is positive. When the number or letter is negative, you must put this sign, as the entire question will be wrong. This sign is of very great importance. Don't just focus on the number and not the sign. Right? Is that clear to everybody? Okay, great. Next, we have the C, which is the letter that is not attached to an x or x squared value. In this case, is going to be 225, which does not have an x or an x squared value attached to it. So C is going to be 225. A is 1, B is negative 60, and the C is 225, which means we can now put those numbers into the formula, quadratic formula, right? The formula is your friend. I admonish you to learn this by heart, but remember this formula was also on the inside cover of the test paper for papers 1, 2, and 3. Be very familiar with this formula. It's best to write it in this format so you can put it into the calculator and you will not have a problem, right? B squared minus open brackets 4 times A times C close brackets. And at the bottom, it's 2A, which is the same as saying 2 multiplied by A. This may be a good format for you to increase your accuracy, right? That's step 2. Step 3 involves you putting in the values. So B is negative 60, so you simply put in negative 60. Now, very important point. This is not just B, right? It's negative B. This negative sign is this negative sign, right? And this negative sign is actually this negative sign. You'll see that? Let me know. Put it in the chat if you'll see it. Hey guys, you'll see it? Let me know. All right. So don't get them confused. This negative sign relates to this negative sign, which is part of the formula, which is always there. It is always there forever. That's part of the formula. Whereas this negative sign here is going to be related to this negative sign. And sometimes the B is negative and sometimes the B is not negative. Very important. Be on the lookout for that. But not because the B has a negative sign, you forget about this negative sign and thinking the erroneous thought. Here's the erroneous thought. You're thinking that somehow this negative sign is now this negative sign, right? If you do that, that's going to be completely incorrect. This negative sign has absolutely no relationship with this negative sign. This negative sign is part of the formula forever, right? So are we clear with this? So the conclusion is you must put in both negative sign from the formula and the negative sign from the B. All right, awesome. Next, we're going to take this and work it out in parts. Okay, so the negative 60, when you work that out, it's going to be positive 60. You use a calculator, that's what you're going to get. Press the plus or minus button, by the way, for the calculator that I suggested. You press the plus or minus button, open brackets, plus or minus button again, 60, close brackets, you will get 60. All right, awesome. Next, let's work out this part here. This is called the discriminant, not very important, but we're going to work this part out separately. Just like this, it's going to be negative 60 squared. When you put this into the calculator, negative 60 becomes 3600. Take away sign, 4 by 1 by 225 gives me 900. The reason why I put this into a bracket, so in case one of these have a takeaway sign, you will not get the takeaway signs or the minus signs confused, right? This is a safe way to always get the right answer. If you put this exactly as is written here into the calculator, if you have a DAL calculator, you're going to get 900. Okay? Minus sign, and then we just take them away. 3600 take away 900 will give me 2700. And then find the square root of that. That's going to be our result later on. But now we're going to look at getting 2 times 1, which is 2. So we worked out the 3 major areas. That makes it a little more interesting and less cumbersome. The B section, the negative B, the discriminant or the thing under the square root sign, awesome, and the denominator. Once you have those, then what you do next is we're going to look at Let's clear those check marks. The simplified form, right? The 60 comes here, plus or minus button, square root of 2700 all over 2. How you all feel about this method? Pretty much straightforward. Yeah? You all messing with it? Awesome. Next, we are going to get the square root of the 2700. That will be 51.96. And at this point, let's choose our adventure. Which one do you want to do first? Plus or minus? Right? So in this case, we choose the plus first. Right? So it's going to be 60 plus 51.96 divided by 2, which gives me 55.98. And then it's going to be 60 take away 51.96 divided by 2, which gives me 4.02. So the solution to this is going to be 56.0 and 4.02. Notice we did it to 3 significant figures. Now, ordinarily, 0 is not a significant figure, right? But we need to have it to 3 significant figures nonetheless. So in this case, 1, 2, 3, you circle the 9, you underline the 8, we add 1 to the 9 to make it 10. That's where we get the 0 from. And then the 5 plus 1 from the 10 will give me 6. So this is 56.0 to 3 significant figures. And this number here is also 3 significant figures. Something very important to note, in this case, the 0 is significant because it is between 2 non-zero digits. And it's also a placeholder. Okay, so these are as per CSEC specifications in both instances. All right, awesome. That's the answer there for part 2 rather. How y'all think of what y'all think about this method? You like it? You think it's cool? Not so cool? What y'all think? Put it in the chat. Let me know what's up. So that's the solution to this quadratic equation. Next, we're going to be looking at the total area of the 2 seed beds. Calculate the total area of the 2 seed beds. How are we going to do that? Simple. On the quadratic formula, we're going to be choosing which one to use. And which one should we use? What do you think? 56.0 or the 4.02? Remembering that the x represents the length. Remember that? The x actually represents the width, rather, of the rectangular seed bed. So if the width is actually 56, then the total amount of mesh cannot be 60. It will be 100 and something. Okay? For the both seed beds. So we cannot choose 56. We'll have to choose 4.02. Who understands that? Since the total mesh length is 60 meters, the x, which is the seed bed A, width cannot be 56.0. Again, this is a read the room moment. You don't have to work out stuff and get a negative answer that I will show you how we get later on. You can just simply use your reasoning skills, right? And realize that there's no way that x can be 56 because the total mesh length is 60 and 56 is very close to 60. So imagine the rectangular seed bed width is close to 60. How much will be the total seed bed length, perimeter, sorry, for the rectangle and the square? It will be in excess of 60. You all can see that, right? Yeah? So we must disregard 56.0. So that tends to happen as well. This is a reasoning skill, and CSEC will use this question to test your reasoning skills. Whether you can reason logically that 4.0 is a better candidate for x and not 56.0. Both answers come out from the quadratic. But mathematical reasoning tells me I must choose one, and I must have a good reason to choose that particular one. Is that crystal clear to everybody? What you all think? Put it in the chat, put it in the comments. Hey guys, awesome. Let's continue. So x is going to be 4.02. And recall that the seedbed B side length, right, is going to be 15 minus 2x. You remember that? And I'm going to put x 4.02 into here, and I get 6.96. Again, if I had put 56.0 into here, I've got a negative number, which will be the length of the square seedbed. And you cannot have negative lengths ordinarily, especially at CSEC level for mathematics, right? So if we know what y is, the length of the seedbed B, which is the square, and if we know the 4.02, which is the width of the rectangular seedbed, which is seedbed A from before, you'll recall that, go back into the video, then we can clearly figure out the total area, which is the area of the rectangle plus the area of the square. What's the area of the rectangle? It's going to be 3x by x, area of the square, y times y, 3x squared plus y squared. Then we're going to replace this x with 4.02 and this y with 6.96. When you do that, you simply get 96.9 meters squared. How you all feel about that? Hey guys, great, awesome. So in the final answer, the area of the total area actually of the two seedbeds is going to be 96.9 meters squared. All right, let's press on. Question 3 deals with these topics: trigonometry in right angled triangles, finding heights using sine, Pythagoras' theorem, etc. Take a note of these topics very carefully, right? They are a rough guide as what each question will have. The questions in CSEC are not jumbled up all over. Each question has a specific kind of topics, and you'll see that when you examine the syllabus, which is also uploaded to this Google Classroom, right? I'm gonna upload the syllabus as well, so you'll see exactly what I'm talking about. Okay, great stuff. Let's press on. So it says here, a vertical flagpole FP stands on horizontal ground and is held by two ropes, PG and PR. PG and PR. As shown in the diagram below. Okay, PG is 80 meters. We have that. FR is 9.7 meters. Yes, we have that here. And angle FGP is 38 degrees. Yeah, we have that. Awesome. So all this is information. Have your pencil out. Begin to underline appropriately things that make sense to you. Don't just read questions in mathematics, right? Remember to have a pencil at hand to underline and circle important parameters or important things that can help you answer the question well and accurate. Okay? Again, it's not just about doing the mathematics. You must be able to read. And reading is not just saying words. You must understand what you read. And one way to understand is to engage your writing with your hand, like a pencil, underline and circle accordingly. Okay, that's going to change the game of mathematics. That will tilt the odds in your favor. So calculate the height of the flagpole FP. Well, you see that if FP is in a triangle, not just any old triangle, it's in a 90-degree triangle. That's one hint, right? So can we use Pythagoras' theorem? Well, not particularly, because we don't have this length or this length. Can we use one of the ratios, sine, cosine, and tangent? Let's check it out. You want to find FP, which is here, and we have an angle opposite it, all right? So we're going to use something that has an opposite in it. So let's use the SOHCAHTOA that people know, SOHCAHTOA, and determine which one are we going to choose actually. You want to find, we have an angle, right? So we have an angle, so we can find the sine or cosine or tangent of that angle. There's the angle here, you're seeing the angle. So we can definitely find the sine, cosine, and tangent of any angle. So watch carefully how I'm doing this, right? So we can find the sine, we can find sine, we can find cos, we can find tangent. Because you have an angle and you have a calculator, you can find sine of 38, you can find cos of 38, you can find tan of 38. So which one do we choose? Let's go further. We want to find the flagpole FP, which is the opposite. Who has an opposite? Tangent has an opposite. Sine has an opposite. Does cosine have an opposite? No. So what we do is we're going to eliminate cosine, right? He's no longer invited to the party. All right. Next, do we have to get to continue with tan? We need to find what? We need to have the adjacent. Do we have the adjacent with tan? No, we don't have the adjacent. Do we need adjacent for sine? No, we don't need the adjacent for sine. All right. So we don't have the adjacent for tan. Hence, we may need to eliminate tan, but let's see how it goes. So we have sine, yes. We have opposite. We need to find the opposite. Do we have hypotenuse? Yes, we have hypotenuse. Okay. So when you have to find three ticks, use that one. That's the best methodology. So this is going to be, use this particular ratio, sine ratio, as how you choose, right? You understand? Let's briefly go it over again. But we know that FGP is a 90-degree triangle. So can we use Pythagoras to find the height of the flagpole FP? Not quite, because we don't have the other side here. We have the hypotenuse, but we don't have this other side. So let's try the trigonometric ratios. And remember, you have to look at the SOHCAHTOA. All right, you remember SOHCAHTOA? SOHCAHTOA involves sine, cosine, and tangent. Since we have an angle here, yes, we can find, what can we find with the, since we have the angle, we can find what? We can find the sine, cosine, and tangent. However, do we have, what about the other stuff that we spoke about? Yes, we have to find, we have an opposite with tangent. We have an opposite with sine. Do we? Yes, we do. So we have an opposite there. So we can definitely find our opposite with that. But what about the cosine? We have no opposite. So therefore, in that case, we should definitely cancel cosine. Okay. What about tangent? Do we have an adjacent from the diagram FGP? No. We're going to cancel our cosine. Just put an X there by the adjacent. And then we circle the sine because the sine has everything that we want. That's how we're going to choose. You all see that? So that's a great methodology by which you can choose the appropriate trigonometric ratio. All right. All right. Awesome. Let's continue. So based on this now, all we need to do is the values for sine, etc. Consider triangle FGP. 30 is equal to opposite over hypotenuse. You know the opposite, that's what we want to find. Hypotenuse is going to be GP, which is 18. So in that case, we're just going to put in the 18 where the hypotenuse is. And then the thing that we want to find is at the top. So what are we going to do? We're going to multiply. Don't forget that. When the thing that you want to find is at the top, since the thing that we want to find is at the top, we're going to multiply the sine 38 0.1 meters. Any questions there? Who's understanding? Put a Y in the chat. If you're following this, place an N in the chat if you're not so sure. Okay, great. Are you all cool with this? All right. So just looking at this, again, we try to look at the Pythagoras theorem and realize Pythagoras theorem will not be applicable because we only have the hypotenuse. And then we look at the trigonometric ratios, and the question is which one do we choose? We have the angle, we can find sine of the angle. We have to find the opposite, so it has the thing that we want to find, and it has continues. We have that known. That would be a known as opposed to an unknown. Now, sometimes in a question you may have sine and cosine, or sine and tangent, tangent and cosine, or cosine and tangent. Satisfying those, you may have three ticks above each one. So the question, which one should you choose? Choose anyone. That's going to be easier for you. Okay? Any questions with that? Put a Y in the chat if you'll understand it. Place an N in the chat if you're not so sure. Okay, great. Let's move on.